another episode of Sci-Connect. I am Teacher Nell, your science teacher for today. Are you now ready to learn? Let's start! Hello grade 8 science learners! Welcome to our new video lesson for this third quarter, which is all about the particle nature of matter. In grade 7, you recognize that there is a wide variety of materials, and these materials combine in many ways and through different processes. With this diversity of materials, you also learn that chemists came up with several ways of classifying them: heterogeneous and homogeneous mixtures, elements and compounds, metals and nonmetals, and acids and bases. By engaging in simple scientific investigations, you were able to recognize some properties of solutions, which are classified as homogeneous mixtures. You also studied the properties of common elements, compounds, metals and nonmetals, as well as solutions of acids and bases. Into this lesson, it is for you to observe, experience, and represent through drawings, illustrations, or cartoons the different phenomena that will help you gradually understand what the particle nature of matter is all about. You will also learn how to differentiate matter from those which are not matter, and you will look at situations that support the idea that matter is made up of tiny particles which you cannot observe with your unaided eyes. This fundamental idea will enable you to learn that the properties of matter are a result of the arrangement of particle is it made of. Are you now excited to learn more about this? So let's start! Most essential learning competency for this lesson is to explain the properties of solids, liquids, and gases based on the particle nature of matter. The specific objectives are the following: cite evidences that matter is made up of tiny particles, construct models showing particles of solids, liquids, and gases using recyclable materials found in your community, and compare particle arrangement of particles of solids, liquids, and gases using a model. But before we start, let us first define the terms used in this lesson. Atom is the smallest particle of matter. Mass is a measure of the amount of matter the object has. Particles, all matter is particulate in nature, means that between separate bits of matter there are spaces which contain no matter. Volume, measure of the space occupied by an object. Gas, a state of matter wherein particles were randomly arranged far apart and move quickly in all directions. Liquid, a state of matter wherein particles were randomly arranged, have an average distance between each other, move and slide from each other. Particle model of matter is about that describes the arrangement and movement of particles in a substance. And solid is a state of matter wherein particles have a regular pattern or arrangement, very close distance between each other, and vibrates in a fixed position. This time, let's have first the pretests. We have 5 different questions that will be flashed on screen. You can pause the video for a while to analyze each question. Directions: choose the letter of the best answer. Write your answer in your answer sheet. Number 1. All matter is made up of extremely tiny objects called blank. A. Atoms, B. Elements, C. Molecules, D. Particles. Number 2. Red food color combines thoroughly with water. After mixing, this implies that particles in matter are always blank. A. Colliding, B. Bouncing, C. Moving, D. Touching. Number 3. In which states of matter are the particles randomly arranged? A. Liquid and solid, B. Liquid and gas, C. Gas and solid, D. Solid, liquid, and gas. Number 4. Below are particle models of substance X, Y, and Z. Which of the following model represents liquid? A. X, B. Y, C. X and Y, D. Y and Z. Number 5. Which state of matter are particles can be compressed easily? A. Solid, B. Liquid, C. Gas, D. Both in liquid and gas. Congratulations for answering the first 5 questions in your pretest. Are you now ready to do the next activity? Yes! Let's proceed. Directions. Among the materials given in the table, which do you think is classified as matter? Put a check under the appropriate column in Table 1. Give your reason for each sample. And write your answer in the last column. The Table 1 is identifying matter. The samples are sugar granules, water, stone, air inside ball, leaves, smoke. Is the sample matter? Yes, no, or not sure, and provide your reasons for your answer. Based from the activity, what is common in all samples of matter? Is it exciting? Yes. Let's explore more to the next activity. Activity entitled, What Matter is Made of? Materials, 3 teaspoons of sugar, 1 small transparent glass with clean water, half filled, 1 marker, either blue, black, or red, 1 teaspoon, 2 teaspoon soy sauce or tuyo, 1 dropper optional, 1 stirrer plastic coffee, stirrer or hard plastic straw. Taker. Clean all glassware and containers very well since you will be tasting the mixture. Procedure. Number 1. Using a clean small transparent glass half filled with water, mark the level of water with marker. Number 2. Measure 3 teaspoons sugar, then transfer it to the small transparent glass with water. Number 3. Mix thoroughly until all the sugar dissolves. Taste the resulting solution. Question 1. What is the taste of the resulting mixture? Please take note, you have to write your answer in your activity notebook. Number 2. Question number 2. Think about sugar and water as made up of tiny particles. Give your reasons for the observations you made in question number 1. Number 4. Put the solution on top of the table and observe the volume. Question 3. What can you say about the volume of the sugar and water mixtures? Question 4. Is the volume of the resulting sugar mixture equal, more than, or less than the volume of the unmixed sugar and water? Question number 5. Think about sugar and water as made up of tiny particles. Give your reasons for the observations you made in question number 3. Number 5. Get another small transparent glass and pour tap water up to the rim. Number 6. Add 3 drops of soy sauce slowly along the side of the transparent glass. Question number 6. Describe what you observed after adding the soy sauce. Number 7. Set aside the glass with soy sauce in one corner of your kitchen without disturbing the setup. Describe the appearance of the contents of the glass after 1 day. Compare it with the appearance when you left the glass the previous day. Question 7. What happens to the soy sauce dropped in the glass containing water? Write your observations in your notebook. Question number 8. Think about soy sauce and water as made up of particles. Give your reasons for the observations you made in question number 6. Reminder, don't forget to submit your answers to your science teacher. Keep this in mind that matter deals with very small particles beyond what your eyes can see. In fact, the ancient Greek philosophers proposed ideas about what matter was made of. Almost 2,500 years ago, Leucippus and his disciple Democritus believed that nature consisted of 2 things: atoms and the void that surrounds them. They believed that atoms are physically but not geometrically indivisible. For Democritus, atoms are indestructible and completely full, so there is no empty space. Both Leucippus and Democritus had the idea that there are many different kinds of atoms and each of them had specific shape and size, and that all atoms move randomly around in space. Democritus believed that any piece of matter can be divided and subdivided into very small particles, but that this process ended at some point when a piece is reached that could not be further divided. He called this particle atomos, a Greek word which means indivisible particle. Democritus' ideas about the atom were later challenged by other Greek philosophers, most strongly by Aristotle. The idea of the atom was not further explored until a little over 2 centuries ago when John Dalton presented concrete evidence that all matter is made of very small particles called atoms. An atom is the smallest particle of an element that has all the properties of the element. Today, we know that although atoms are very small, they are not indivisible as Democritus thought. Rather, they consist of still smaller particles. Democritus was right in one aspect of his belief. That is, atoms are the smallest particles of which substances are made. To understand further about this lesson, let us explore activity number 2, entitled Resiklo mo, Model ko. Instructions: in this activity, you will construct models showing particles of solids, liquids, and gases using recyclable materials found within your community. This time, you're going to act like a scientist and will be tasked to do the following. Number 1, plan your own activity. Include in your plan the following: A. Objectives. B. Materials. C. Procedures, which includes guide questions. Letter D. Data and observations. E. Desired output. Number 2. Your output will be rated according to the rubrics given on the next slide. This is the rubric of your model. Have a look. Reminder, don't forget to submit your model to your science teacher. Next activity that we are going to explore on this lesson is activity number 3, Model Ko Sikap. At the end of this activity, you should be able to, number 1, construct particle model of solids, liquids, and gases using recyclable materials found in your community. And number 2, compare particle arrangement of particles of solids, liquids, and gases using the model you created. Materials needed: permanent marker pen, cutter, roller or tape measure, masking tape, pair of scissors, nails, tie wire or sturdy barbecue sticks, glue stick, 100 pieces plastic bottle caps, pliers, 36 pieces blue caps like bottled mineral water cups, 24 pieces reed caps like in situ bottle cups, and 16 pieces white caps like in bottled mineral cups. Safety precautions. Number 1, be careful when handling and using the scissors and cutter. Number 2, protect your eyes and skin from melted glue stick because it may cause injury. Procedure. A. Solid particle model. Number 1, prepare all color blue plastic cups for this solid particle model. Number 2, plug in the glue gun. Number 3, start to glue one cup to another cup by putting small amount of hot glue on the center of each cup. Number 4, continue to attach another cup until you create the desired shape of solid particle arrangement. Letter B, liquid particle model. Number 1, prepare all red color plastic cups for this liquid particle model. Number 2, measure and cut 12 pieces 8 inches long, tie wire or hard barbecue stick. This will serve as the connectors of the particle model. Number 3, light the candle and bring the nail near the flame. Number 4, when the nail is already hot, make a small hole in each side of the cup, just enough to fit in the tie wire or sturdy barbecue stick. Number 5, continue to attach another cup until you create the desired shape of liquid particle arrangement. Letter C, or gas particle model. Number 1, prepare all color white plastic cups for this gas particle gas model. Number 2, measure and cut 12 pieces 8 inches long tie wire or hard barbecue stick. This will serve as the connectors of the particle model. Number 3, light the candle and bring the nail near the flame. Number 4, when nail is already hot, make a small hole in each side of the cup, just enough to fit in the tie wire or sturdy barbecue stick. Number 5. Continue to attach another cup until you create the desired shape of gas particle arrangement. Your output will be rated using the same rubrics used in Activity 2. Don't forget to submit your output to your science teacher. Keep this in mind that the particle model of a matter more than 2,000 years ago in Greece, a philosopher named Democritus suggested that matter is made up of tiny particles too small to be seen. He thought that if you kept cutting a substance into smaller and smaller pieces, you would eventually come to the smallest possible particles, the building blocks of matter. Many years later, scientists came back to Democritus' idea and added to it. The theory they developed is called the particle model of matter. It is a model that describes the arrangement and movement of particles in a substance. The model is used to explain the physical properties of solids, liquids, and gases. The particles in the model could be atoms, molecules, or ions, depending on the type of substance. There are 4 main ideas in the particle model, as you can see in our screen. Number 1, all matter is made up of tiny particles. Number 2, the particles of matter are always moving, as what you can see on the picture. Number 3, the particles have spaces between them. Number 4, adding heat to matter makes the particles move faster. Scientists find the particle model useful for 2 reasons. First, it provides a reasonable explanation for the behavior of matter. Second, it presents a very important idea. The particles of matter are always moving. Take note, the particles of matter are always moving. Matter that seems perfectly motionless is not motionless at all. The air you breathe, your books, your desk, and even your body all consist of particles that are in constant motion. Thus, the particle model can be used to explain the properties of solids, liquids, and gases. It can also be used to explain what happens in changes of state. Now that you have already constructed models of particles for solids, liquids, and gases, and were able to compare its particle arrangement, let's extend your understanding a little further by answering the next task. Write your answer in your answer sheet. Number 1. Why is it that you can still smell the aroma of pork adobo which your mother is cooking even though you are in the living room of your house, which is quite distant from your kitchen? Number 2. Why do you think a pitcher of liquid orange juice flows smoothly when you transfer it to another container? Congratulations! We have done so far all of your activities on this lesson. Let's proceed now to post-test. Directions: choose the letter of the best answer. Write your answer in your answer sheet. Don't forget to submit your answers to your science teacher. Number 1. The particles of substance Y exhibit the following characteristics: has regular pattern or arrangement, closely packed, and vibrates in fixed position. In what phase of matter is substance A? A. Solid, B. Liquid, C. Gas, D. Plasma. Number 2. Which of the following phrases best describes the movement of particles in a liquid? A. completely unmoving. B. Less freely moving than a solid. C. More freely moving than a solid. D. More freely moving than a gas. Number 3. Element nitrogen has a far, random particle arrangement and moves quickly in different directions. This is an indication that nitrogen is in what phase of matter? A. Solid. B. Liquid. C. Gas. D. Plasma. Number 4. While you're heading home, you smell the aroma of a fish being fried. Then you suddenly had a thought that you will be having a fried fish for dinner. This is an evidence that gas particles are long. A. Very close to each other, they are moving fast. B. Very close to each other, they are moving slow. C. Far apart from each other, they are moving fast. C. Far apart from each other, they are moving slow. Number 5. Which statement about the particle theory of matter is true? A. The particles in a liquid have more kinetic energy than the particles in a gas. B. A solid stays in one place because its particles are at rest. Letter C. When a solid melts, its particles no longer exist. Letter D. The particles that make up matter are too small to see without a microscope.
Congratulations, learners, for finishing the visual lesson. I hope you enjoyed learning with me today. Remember, learning is fun with Sci-Connect.